Today we're going to learn how to calculate activation energy giving values of K and temperature. Here we have a data set, and in this data set you see we have values of temperature and values of the rate constant in K. And the unit is S to the -1, and that will be constant. What I would like to do is use these values to determine activation energy. In order to accomplish this, we need to change the temperature in Celsius to Kelvin. The second thing we need to do after take the temperature and take the inverse of the Kelvin temperature. And then we also need to take the natural log of the rate constant at different temperatures. Please do that at this time. When you've changed the temperature and take the inverse, you should have received these values. And we've taken the natural log of the rates constant, you should have received the values for the natural log of K that I've listed here. The next thing you want to do is make a graph of the natural log of K on the y-axis versus 1 over temperature, which is in Kelvin, on the x-axis. After you've done this, you'd like to determine the slope of the line, which is change in y over change in x. Your y value will be the change in natural log of K, and your x value will be the change in 1 over the temperature in Kelvin. Please do that this time. When you graph the slope, your graph should look something like this. You have a negative slope, and you want to pick 2 points on this line and determine its slope, which is of course negative. The value of the slope is, from the slope we can find the activation energy, because the slope of the line is equal to negative activation energy over R. Remember, when we do this, that the R value we use should be this R value here. We're going to use the 8.31, which is in joules per mole K. And keeping that in mind when we're doing the activation energy, usually we express activation energy in kilojoules, so you may want to convert your joules to kilojoules. And notice the value of the slope of the line. After doing this, you should find an activation energy of about 160 kilojoules per mole. Part B of this was to determine the rate constant at a different temperature that was not given on the data set. This temperature was given as 430 K. What you should do is use any point from the data set at a certain temperature and a given K, and then insert 430 for this 430 right here. Insert that for T2, and then you'll be solving for K1. You'll be solving, I'm sorry, for K2. Your K1 and your T1 should correspond. They should be could be the first temperature and your first rate constant, or any two that just correspond from the experiment. Go ahead and calculate it at this time. When you've calculated these, your final answer should be 1.0 times 10⁻⁶ seconds to -1.